Today we will study Coulomb's law in vector form, but before that we will have a little revision of vectors which we have studied in class 11th. So suppose here we have a point. This is a point P. Say it is x1, y1, z1, and here is another point, say Q. It is x2, y2 and z2. If we want to draw the position vector of these points, then we will draw these coordinate axes here, x, y and z axis. This is origin. Now if we draw this vector OP, this is suppose vector R1. It is vector R1. You can write it as vector OP also. This is the position vector of point P. And similarly, this is vector R2. That is position vector of point Q. Now, if we join P to Q, this PQ, from P to Q, it is written as vector either PQ or we write as 1 2, from 1 to 2, vector 1 2. You can write it as vector PQ. And if you apply here the triangle law of addition of vectors, then in this triangle OPQ, this OA OP plus PQ, vector OP, this vector OP plus vector PQ, this will be equal to the closing side of the triangle OQ, vector OQ, or you can write it as vector R1, this vector R1 plus vector R1 2, it will be equal to vector R2. And if we transfer this R1 to that side, then this vector PQ, that is P to Q, this distance PQ, that is vector R1 2, it will be equal to vector R2 minus vector R1. Here you have taken P as x1, y1, z1. So vector, this position vector R1, it will be equal to how much? This R1 in terms of this is x component, this is y component, and this is z component. As you know that we denote unit vector in x direction by I cap, in y direction by unit vector in y direction as j cap, and unit vector in z direction as k cap. So the position vector of point P, vector R1, is equal to how much? It is x1 I cap plus y1 j cap plus z1 k cap. Similarly, this R2, position vector of point Q, it is equal to x2 I cap plus y2 j cap plus z2 k cap. And if you want to find this R12, so you will subtract R2 minus R1. From here, this vector R12 will be equal to how much? This will be R2 minus vector r2 minus vector r1. Now put the values. This is x2 minus x1. Take I common. Remember x2 minus x1 I cap plus y2 minus y1 y2 minus y1 j cap plus z2 minus z1 k cap. Here it will be z2 minus z1 k cap. Clear? You can write it as, what is the duster? Okay, this is z2 minus z1, z2 minus z1 k cap. Clear? So this is vector r12 from P to Q, or this displacement between point P and Q given by vector r12. Vector r12 is this much, and the magnitude of this vector, that is r12 cap. This r12 cap is equal to mod vector r2 minus vector r. Suppose this is equal to how much? It is equal to r. Similarly, if suppose in place of finding this displacement from P to Q, we find displacement from Q to P, from this side, that is from Q to P, in this direction, from Q to P, this one, Q to P. So it is written as, from Q to P it is written vector 2 1 r 2 1, vector r 2 1, from this point to this point. Say this point is 1 and this point is 2, or point P or Q. 2 to 1, displacement from 2 to 1 in this direction. In this direction, 2 to 1. As you have written, the r12 is equal to this much. So if you want to find r21, it will be r1 minus r2. You can write this as this is r21. It will be equal to how much? If you apply triangle law of addition, you will write r2 plus r21 is equal to how much? r1. Apply the triangle law of addition of two vectors. This r2, vector r2 plus, from 2 to 1, r21 is equal to how much? Third side, the closing side is OP, and it is vector r1. And if you want to find this r21, this vector r21, then it will be equal to vector r1 minus r2, transfer this side, minus हो जाएगा, r1 minus r2. r1 is this much, r2 is this much. So r1 minus r2, you will write that x1 minus x2. It will become x1 minus x2 I cap plus y1 minus y2 j cap plus z1 minus z2 k cap. Clear? This is r21. The value is same. The magnitude r12 and r21 are same, but the direction is different. It is from 1 to 2 and this one is from 2 to 1. So we have calculated this. We will use this in Coulomb's law in vector form. So I have told this as a revision. And if you want to find the magnitude, you will take mod of this. And also you have calculated the unit vector. Suppose we want to find unit vector in the direction of unit vector in the direction of r12. Unit vector in the direction of r12. Unit vector in the direction of vector r12. So what you do? We just divide this vector by its magnitude, and it is written as r12 cap. R12 cap vector r12 divided by its magnitude. Its magnitude is written as r12 vector ka mod of this, or you can write it as vector r12. Suppose this magnitude is equal to r. You can write like this. The unit vector in this direction r12 is this one. Similarly, unit vector in the direction of r21 in this direction, that is this r21 cap, it will be equal to how much? It will be vector r21 divided by mod r21, or vector r21 divided by r. Because the magnitude is same, r12 magnitude and r21 magnitude same, suppose it is equal to r. I think you have got it. Now come to our topic. Coulomb's law in vector form gives magnitude as well as direction. For this, as you know that if the two charges are of same nature, suppose these two charges are positive charge, this q1 and it is q2, separated by distance r. So there will be repulsive force, they will repel each other. There will be repulsive force, they will repel each other. Similarly, if suppose these two charges are minus, both are minus, again they are of same nature, so there will be repulsive force again, they will repel each other. Okay. Now in this case here, these two charges are suppose of opposite, this one is plus and this one is suppose minus. So they are of opposite nature, so they will attract. They will attract each other. So if same nature, there is repulsive force, and if they are opposite, they attract each other. And the magnitude of this force is given by this formula: F is equal to K Q1 Q2 by R square. You know it? This is the magnitude of the force. The force acting on this charge, or the force acting on this charge because of this one, it is given by this formula. This is the magnitude, we have studied it. Here we want to find the direction of this force also. This force always acts along the line joining the two charges. For this, consider two charges. Suppose this is the Q1 charge, and the position vector of this charge is R1. This is vector R1. And the charge is here suppose Q2, and its position vector is this R2. Position vector is R2. Now, the force will act along the line joining these two charges. The displacement vector of charge Q2 from Q1. The displacement vector of charge Q2 from Q1 is shown like this. In this, from Q1 to Q2. This is displacement vector of charge Q2 from Q1 to Q2. From Q1 to Q2, from 1 to 2. It is written like this. And the displacement vector of charge q1 from q2 it is written like this. From q2 to q1 it is r21. Clear? Now the repulsive force, these two charges are repelling each other. The repulsive force will be along this direction. The force acting on charge q2, it will be along this direction, and this force is written as F, force acting on charge q2 due to q1, it is F21. And force acting on charge q1 in this direction, it is written like this, and it will repel and it will move away. It is written F. It is written F12. F12 is force acting on charge q1. So displacement vector of charge q2 is from q1 to r12, and displacement vector of q1 from q2 is r21. Now note down, let two charges q1 and q2 are placed as shown in the figure. Their position vectors are r1 and r2. Here F12 is force acting on charge q1 due to q2. F21 force acting on, write down, force acting on charge q2 due to q1. Vector r1. What is this? Position vector of charge q1. Position vector of charge q1. And this r2, vector r2, position vector of charge q2. Position vector of charge q2. R12. What is R12? R12 is displacement vector of charge q2 from q1. Displacement vector of charge q2 from q1. R12. Similarly, R21. What is R21? It is the displacement vector of charge q1 from q2. R21. And R12 cap. It is unit displacement vector from q1 to q2. Unit displacement vector from q1 to q2. q1 to q2 means in the direction of force F21. And R21 cap. R21 cap is the unit vector in the direction, unit displacement vector in the direction q2 to q1. That is in the direction of force F12. So this unit vector is in direction of this force. This unit vector F21 in this direction. This is the unit vector. This is R21 cap. It is in the direction of F12. And this is the unit vector R12 cap. It is in the direction of force F21. R12 is in the direction of F21. Now, how can we write the formula in the vector form? So, the magnitude will be same. We will just write it with the help of these unit vectors, and that will give the direction. Direction is of this force F12 is in the direction of unit vector R21. So in vector form, it is written as force F12. Which force? That is force acting on charge Q1 due to Q2. F12 is equal to, this is the magnitude. Note down the magnitude first. That is K Q1 Q2 by R square. This is the magnitude. And this R square, that is the displacement vector for this force F12, it will be in the direction this unit vector R21. We need this R21 vector. So magnitude of this R is equal to mod R21, and of course this is also equal to R12. Magnitude is same, so you can write it here either R, or just remove this arrow and this mod. You can write this like this, R12 simply, or R21, and this is equal to R12. When you will not put an arrow here, it represents only the magnitude. So F12 is equal to this much. Which unit vector will be used here? The unit vector used to show the direction of where F12 is R21. Here you will write as R21 prime. Clear? You can also write its value in the terms of R here. This F12 is equal to K Q1 Q2 by R square. This is the magnitude. And unit vector R21 cap. This R21 cap is nothing but vector R21 divided by its magnitude. R21 magnitude R21. It is written in terms of this R21. We have written that this is equal to R. So we can write here this as vector R21. Vector R21 divided by vector R. Magnitude of vector 21. So it will become F12 is equal to K Q1 Q2 by R cube. Vector 21. Clear? Similarly, when we will find force this F21, that is force acting on charge Q2 due to Q1, that is F21, what will we write? That is similarly force acting on charge Q2 due to Q1, that is F21. Magnitude will be same, that is K Q1 Q2 by R cube, and this force F21 is in this direction, that is in direction of R12. So we will write here vector R12. And if you want to write in terms of unit vector, what you will do? In terms of unit vector, it will be like this. F12 is equal to magnitude K Q1 Q2 by R cube. In place of R cube, here we will write as R square, and unit vector 1 2 10. In some books, force F21 in direction of force F21, it is written as also R21, and for F12 it is written R12. So it totally depends upon your assumption. In different books it is written in different way, but here I find it is easier to write in this way. Okay. So we have got the result. Force acting on charge 1, F12 is equal to this, and force acting on charge Q2 due to Q1 is this. These two forces are equal in opposite, that can be shown since the unit vector R21, this R12 is equal and opposite to this. Therefore, this F12 will be equal to minus F21. That is, these two forces are equal and opposite. Now we will do a numerical based on this Coulomb's line vector form. 2 point charges Q1 is equal to 2 Coulomb and Q2 is equal to 6 Coulomb are placed in free space with position vectors R1. Vector R1 is equal to this meter and R2 is equal to 5 I cap plus 8 j equal to 4 k cap meter respectively. Find the force between the two charges. Okay, here position vector R1. This R1 is equal to how much? 3 I cap plus 9 j cap plus 6 k cap. And R2 is equal to how much? 5 I cap plus 8 here, 8 j cap plus 4 k cap. Therefore, displacement vector is R12 will be equal to how much? It will be equal to vector R2 minus vector R1. That is this 5 I cap minus 5 I cap plus 8 j cap plus 4 k cap minus 3 I cap plus 9 j cap plus 6 k cap. 5 minus 3 we will get it is equal to 2 I cap. 8 minus 9 will be minus j cap and 4 minus 6 will be minus 2 k cap. This is the displacement vector R12. Similarly, if you want to find this unit vector, this R12 cap, then it will be equal to how much? It will be this R12 vector mod, that is 2 I cap minus j cap, this minus 2 k cap mod the under root 2 square plus minus 1 square plus minus 2 square, that is 2 to the 4 plus 1 plus 4, 9 root, that is 3 meter. So the distance between the two charges is 3 meter. We have got it. Sorry, this is the magnitude. We are calculating magnitude of the vector, and this magnitude divided by magnitude of vector. Sorry, it is the magnitude of the vector, this much. And if you want to find unit vector R12 cap, so this vector R12 divided by the magnitude is R12 mod, that is 2 I cap minus j cap minus 2 k cap divided by 3. This is the unit vector. Clear? So if you want to calculate F12, then you will find this unit vector R21. Similarly, we can find this. This is R12. We can find R21. R21 is R21. Vector R21 is equal to how much? It will be R1 minus R2. The value will be same, just sign will be changed. It will become minus 2 I cap plus j cap plus 2 k cap meter. This much meter. This implies that the unit vector R21 cap will be how much? It will be again vector R21 divided by mod r21, it will be the same to, this is minus 2 I cap plus j cap plus 2k cap divided by 3. Clear? So we have got these two, that is unit vectors in the direction of F12 and F21. Now we will find the force. Suppose we want to find this force. We will find F12, force acting on charge Q1. F12, this F12 will be K Q1 Q2 by R square. Here is the magnitude of this vector R2. This R12, it will be equal to unit vector R21. Right. Now put the values. We will have this K is 9 into 10 to the power 9. Q1 is 2 coulomb. Q2 is 6 coulomb. And the value this between the distance between the two charges has come equal to 3. 3 square into unit vector R21. Unit vector R21 is this minus 2 I cap plus j cap plus 2k cap divided by 3. 3 3 are 9 and 3 is cancelled out 2 and this will be cancelled out by 9. So we will have here 2 to the 4. 4 into 10 to the power 9 and this is minus 2 I cap plus j cap plus 2k cap. This much, this is the force, so unit will be Newton. This much Newton. You can write it as this will be 4 to the 8 minus 8 into 10 to the power 9 I cap plus 4 into 10 power 9 j cap plus 8 into 10 to the power 9 k cap Newton. This is the force acting on charge Q1 due to Q2. Similarly, we can find this F21. This F21 will be same in values. The only difference is of sign, because F21 is equal to how much? Minus F12. So we will change the sign. This will become plus, that is 8 into 10 to the power 9 I cap. This minus 4 into 10 power 9 j cap, and this is minus 8 into 10 power 9 k cap Newton. Clear? You can write this 10 power 9 by taking some common, this 4 into 10 power 9 common like this. Clear? So in this way we will solve the numericals based on Coulomb's law वेक्टर फॉर्म. तो बच्चों इस पे आप और न्यूमेरिकल करिए. हम लोग फिर मिलेंगे अगले वीडियो में. तब तक के लिए बाय बाय.